In this lecture, we'll be looking at laws of exponents. We're going to look at intermediate laws. So these are going to be a bit more advanced than the basic. Now here are the areas we're going to look at. Fractional exponents. We're going to look at exponent of an exponent, expressions with exponents, and exponent of a product of terms. So we look at fractional exponents. In this, we're looking at two cases. One of them is you have 1 as the numerator, and then you have another integer as your numerator. So in this case, where you have 1 as your numerator, what ends up happening is the denominator of the fraction becomes the root of the number, and the numerator here becomes the exponent of the number. So let's look at it this way. So 25 to the power of 1 over 2 is the same as 25. The root is going to be 2, which is the square root, so we usually ignore it, and that's going to give us 5. This right here, the root is 2, so you're just going to have the square root of x. Now notice that I am not doing anything to it because the numerator is 1, the numerator is 1, so your exponent here is 1. So that's kind of how it works. Now let's look at instances where we have a numerator that is not 1. So we apply the rule. The denominator is the root, so we have a 3 here, 64, and then this is, or you can write it this way, the root 64, and then you can square it. So this is going to give us 4 squared, which is 16. Now in this case, we have the root here is 7, and then y to the power of. So we look at exponent of an exponent. So in this case, we have an exponent and then we have an external exponent. So when you have this case here, you're going to multiply the exponents together. Notice there's a difference between this and when you have an exponent multiplied by another exponent. So here, the distinction is this is the exponent of an exponent. So in that case, we multiply the exponents together. So this is 3 to the power of 4 times 5, which is 3 to the power of 20. Another example of this type here. So this is b to the power of 3 to the power of 2. So this is b to the power of 3 times 2, which is b to the power of 6. Now let's look at expressions with exponents. So if I have an expression, in this case we have a fraction here, and then we have an exponent. What this means is that every term in the expression is affected by the exponent. So in this case, you have a over b to the power of n. So this is going to give us a to the power of n divided by b to the power of n. So in our example here, we have 4 over 5 to the power of 2. So this is going to give us 4 to the power of 2 divided by 5 to the power of 2, which is 16 over 25. So here we have 2x to the power of 4 over 3y to the power of 4. So we'll leave it at this, and then the next rule will show us exactly what we do with this. So in this case, we have to the power of 0. So this is 4x to the power of 0 divided by y to the power of 0, which is 1 over 1, which is 1. Or you could just ignore all of this stuff here, and because it has an exponent of 0, it's automatically 1. Now let's look at exponent of a product. So 2x is a product of 2 and x. So here's what happens here. It's going to be 2 to the power of 3 x to the power of 3. So this is going to give us 8x to the power of 3. So here 4ab, so that's 4 times a times b, so it's going to be 4 squared a squared b squared. So this is going to give us 16a squared b squared. Now we can apply that rule over here. It's going to give us 2 to the power of 4 x to the power of 4 divided by 3 to the power of 4 y to the power of 4. This is going to give us 16 x to the power of 4 divided by 81 y to the power of 4. So these are the important rules. The next topic will cover how to apply all these rules together to solve complex expressions.